This short video is about specific latent heat of vaporization and fusion. There's an equation and a question along with the answer. If you want to look for more resources, you'll find some more GCSE resources at my shop on the Times Ed. Please press subscribe and like at the end of the video. Definitions. Specific latent heat of fusion, LF, is the energy required to change the state of 1 kilogram of a substance from solid to liquid. This is the important bit, without changing the temperature of the substance. So, the latent heat of fusion, we're going from solid to liquid, and it's the energy divided by mass, joules per kilogram. You can rearrange it to give you E, the energy, equals the specific latent heat of fusion times the mass, or if you like, you can rearrange it to get the mass. If you want to have a quick go at rearranging it yourself, it's E divided by LF. Okay, the specific latent heat of vaporization, LV, is the energy required to change 1 kilogram of a substance from a liquid to a gas, again, without changing the temperature. LV equals E divided by M. The units are joules per kilogram, and we have E equals LV times M. And again, M would be E divided by LV. Just to reiterate, the units for mass are kilograms. The units for energy are joules. If you want power, it's joules per second. Just because that's one of the questions. Now, you may have seen a curve for heating of water, which starts at 0, ends at 100, and it's solid being heated. This is time on the bottom axis. And it's being heated by a constant amount all the time, and then it gets to 100, and then it stays at 100. And the change of state is occurring here, where the energy goes into changing the state, and again, changing state here from this point onwards, and that point. Here, the energy goes in the middle section, the energy goes into changing the temperature of the water. At these two sections, A and B, the energy is going into changing the state from liquid to a gas, and from at A, from a liquid to from a solid to a liquid. So that's a heating curve for water, and the side there is degrees C. Okay, let's have a look at a question then. A question using the results table below. Let's take a quick look at the results table, and then you can have a go at the question. So we've got time here on the top, state, as in what's happening to the liquid. Obviously, it's the liquid, and then we've got temperature underneath. A student heats 200.0 centimeters cubed of water for 11 minutes. Okay, so that's the 11 minutes at the far end. After 11 minutes, the student removes the water and there is 50 millilitres left, 50.0 millilitres left. The specific latent heat of vaporization of water is 2.26 megajoules per kilogram. What was the power supplied by the water heater? Okay, so things to note. Water boils at 100 degrees C. When did it reach 100 degrees C? 5 minutes. So how long was it being heated for? It was being heated at 100 degrees C for 6 minutes. So from there to there, the water is boiling. So all we can do is work with the times we've got. We don't know whether it started boiling at 5 and whether it stopped exactly at 11. It's for 11 minutes. So yes, we do know that it stops at 11. and didn't carry on till the 12th minute. The Cific latent heat of vaporization of water is 2.26. We've got some different units here. We've got 3 different units going on, 4 different units going on, and they're not what we want them to be. So 200 centimeters cubed. We've got 50 milliliters. We've got 2.26 megajoules per kilogram, and we've got 11 minutes. Okay, so we need to change those to the units that we want. So that is 200 grams water for 1 centimeters cubed is a gram. 1 centimeter cubed is 1 milliliter. So we have 50 grams. Mega is a million, so that is 2,260,000 joules per kilogram. And 11 minutes, so that would be 11 times 60 for seconds. I'm not going to finish it off because we don't need that. We need 11, we need 11 minus 5. 11 minus 5, which gives us 6 times 60 seconds that it's boiling, and that will give us 360 seconds. Okay, let's get on with the actual maths behind the question then. Now I've got all the amounts in the right order. So we've got the energy required equals specific latent heat of vaporization times the mass in kilograms. So that's 2,260,000. That's 2,260,000 times the mass. Well, that's 200 take away 50. But the mass is in kilograms. So we've got to change that. I still haven't changed that enough. It gives us 150 grams or 0.15 kilograms. So it's times 0.15 kilograms, which gives us 339,000 joules just to heat up 150 millilitres of water to turn it to steam. But that's not the final answer. That's the final bit of using the equation that we've got. But the final answer is about the power, and power equals energy divided by time, and in this case it's 339,000 divided by 360 seconds. That will give us 941.6 watts. Now, having a look at the question, I've got 3 significant figures there, 3 significant figures there, 4 significant figures on the 200.0, but I'm going to quote then to 3 significant figures, which is 942 watts, and it's to 3 significant figures. Okay, so just underneath a kilowatt for the strength, for the amount of energy transferred by the heater. Hope you found this presentation useful, and don't forget to press like and subscribe below.